And now, somebody who needs no introduction. Back on back row.
Hello, good morning. You can hear me? Everybody can hear me okay? All right. It's usually not an issue. All right. So today I'm going to talk about cheap and easy cross-deliverable link implementation. Necessary legal disclaimer, this is who I am. If you don't know, I am a wizard. So we're going to talk about cross-deliverable links. So what are they? All right. So this is a feature that we added in DITA 1.3, and it allows you to have cross-references from topics in one publication to topics in a different publication. And this works by making key references through peer map references. So I have a map with a map ref with the scope equals peer, and it has a key scope. And then I have somewhere in a topic, I have a cross-reference that references that scope and that key, and then we have our target, right? So my cross-reference points to the key scope. That key scope gets me to the root map of my other publication, and then my key reference gets me to the key in that target publication, right? So that's how you author these things. All right, where am I going? Why is it not proceeding? Come on, go to the next slide. There we go. Okay, so this is defined in DITA 1.3. So when scope equals peer and you have a key scope, then that specifically means, by the DITA standard, that my target map is a separate root map, right? It defines its own key space, has its own keys. And then scope qualified key references to that scope are resolved in the context of the target map's key space. All right, so why do we call this cross-deliverable, right? So the key refs are authored between root maps. So one of the sort of odd things about this feature is that authoring is easy, right? Oxygen supports it. You just create these references, and as far as Oxygen is concerned, everything's cool and it works. However, the publishing them is hard. So when maps are rendered as deliverables, the resulting links are deliverable specific, right? So in my source, it's just a source-to-source reference, and that's easy. But when I'm going to deliver these things, it becomes really complicated, right? Because there's not a one-to-one mapping between source and deliverable, right? There's a one-to-infinity mapping between source and deliverable, right? And so that adds quite a bit of complexity. So for a given deliverable type, you have to determine what the target anchors are for each link target, right? So I have a topic with a key in my source. What does that become when I publish it to HTML? What does that become when I publish it to PDF? What does that become when I publish it to the thing we haven't invented yet, right? So that's the challenge. And so if you think about the general implementation of this, like if I was to implement this as an out-of-the-box feature in DITA Open Toolkit, right, which will probably never happen for good reasons, but if I was going to do that, what would I have to do? I would have to do a whole lot of stuff to make that work in a general case, including like dynamic generation of source targets to deliverable anchors, right? Which is something the Open Toolkit was never architected for, right? I would have to have, on a per link basis, a way to configure the mapping from links to rendered deliverable types, right? For this particular link, from this topic, in the context of this publication, I want this to go to the PDF, regardless of whether I'm actually generating HTML or whatever, right? I need to be able to make that kind of decision. Nobody's going to do that, right? And it requires a two-pass process because I have to process all the publications in my publication set to determine what the targets are. Having determined what the targets are, I need to republish all the publications in my publication set to then now reflect those targets, right? So there's some complexity there. And for all of those reasons, there's probably never going to be a general solution unless, somebody comes up with a whole lot of money, right? But that's all right. Doesn't matter because in a special case, it can actually be really, really simple, right? So this is sort of an odd aspect of this aspect of DITA, which is the general case nearly impossible to implement. The simple case easy. All right. So that's what we did. So if you have a deterministic mapping from your source targets to deliverable anchors, that is, given knowledge of the source location or the source features of a topic, you can predict what the delivered URL or anchor will be, right? That makes it easy. And that's actually the way that almost every publishing tool that we use works, right? Certainly for HTML outputs, that's the case, right? So if you can predict the URL, it's easy, right? And then if you have consistent deliverable to deliverable mapping, that also makes it easy, right? So if I say, well, when I publish HTML, my links are always going to go to the HTML version of the target publication. And for PDF, it's always going to go to PDF, or for PDF, it's always going to go to HTML because that's actually the only one that works. Or help links go back to the HTML, whatever it is, right? If you can define that rule, then it becomes easy. And then you might have some special cases. So just this last week, we implemented a new feature. So our docs, we publish on docs.servicenow.com. But the same API documentation also gets published to developer.servicenow.com. And we had the problem that in the version of that content, as published on developer.servicenow.com, if you had a cross-bundle link that went to a different API topic, the link would take you back to docs.servicenow.com. But that's not where you wanted to be because you were in developer.servicenow.com, right? So we said, through the magic of keys, we can fix that problem. So what we implemented was when we're publishing an API topic to developer.servicenow.com, we make the cross-bundle link go back to developer.servicenow.com. When that same topic is published to docs.servicenow.com, that same link goes to docs.servicenow.com, right? And that's through just a simple extension to the mechanism that I'm talking about here. But the authored content doesn't change, right? That's the whole point of keys, right? The other thing is you can reduce your 2 passes to 1.5 passes, right? Because your first pass, all it needs to do is figure out what the target anchors are. You don't actually have to do the full rendering, right? So you do what I call a 1.5 pass. All right, so how do we make this work? The magic is what we call delivery key def maps. So we have an XSLT that's applied to all of our route maps. And just for scale, we have roughly, as of today, about 60 different top-level route maps publications that get published to docs.servicenow.com, plus other route maps that get published elsewhere. We have in-product help. We have developer.servicenow.com. We have a new thing that we have just implemented in the last couple of months. But yeah, roughly 60. So it's a lot, right? So we have a dedicated Git repository, which we cleverly call DITA-delivery, which holds these generated key def maps. And then when we publish the full document set, what we call a full family set, because our versions are called families, we generate all of the delivery key def maps from all the route maps first, and then we publish all the route maps to wherever they're being published to. So that's the 1.5 pass process, right? The generation of delivery key def maps is the half pass, and then the full publication is the full pass. We have a Jenkins job that, so in our Jenkins jobs that do our publishing, because we use Jenkins to run Open Toolkit to then do our publishing, we just clone our DITA-delivery repository along with the source repo, and then all the stuff is there. And then to generate these delivery key def maps takes about 30 seconds per route map, right? But we have 60, so it takes about 20 minutes to generate the full set. But still, given it takes about 3 hours to run Open Toolkit across all of our publications and get them loaded onto docs.servicenow.com, that's still a tiny fraction of the total build time, right? So very small overhead. All right, so how do we do this? So I extend preprocess pre. And so this runs before any pre-processing. And so what I do is we have the delivery key def maps in this separate repository, but I need to copy them into the source location so that Open Toolkit won't get freaked out because the maps are not under the main directory structure, right? But I have another reason for doing that. So then on my input map, I rewrite my peer map refs, right? So for every publication that could be a target of a cross-deliverable cross-reference, I have a peer map ref to that publication. So in practice, what that means is every one of our root maps has a peer map ref to every other root map, right? Because it's not practical for us to know for a given publication, well, I only care about these 5 other target maps. I just have to add all 59 of the other ones there, right? So every one of our maps has these peer map refs to all the other maps. So I rewrite those to be local scope map refs to the delivery key def map, right? Having done that, normal OT processing proceeds, right? And that means that the normal key resolution just works. Because what I've done is I've changed what are these peer map refs into just normal map refs that now link to external resources. That is the location of these topics as published on docs.servicenow.com or now on developer.servicenow.com. Right, now there is one small practical problem, which is I have to filter these key defs. So we have about 60,000 topics per version of our product, right? And then we have keys for every topic, right? So that's 50,000 keys. And then we have a comparable number of images. So that's about another 50,000 images. We got keys for all those. So now we're up to 100,000 keys. And then we have keys for variables, of which we have a whole lot, right? So there's somewhere on the order of between 100,000 and 200,000 keys in that any map that we're processing has to have is going to have defined in their context, and that's too many keys, right? Open Toolkit doesn't do well with that many keys. So what I do is I filter out as part of the process of copying these delivery key def maps from their main location to the source location where we're going to actually read them. I also filter out all the keys I don't need. So what I discovered is that through OT 4.1 and now probably still 4.2, unless Yarno, you rewrote the code that I'm sure you have no interest in rewriting, right? The key space construction at this scale just doesn't work. It works fine for smaller sets of keys, but as implemented, just doesn't work for these keys. Basically, it just runs out of memory, and it takes forever, and it never completes. So I had to do this filtering just to make stuff work, but the filtering was easy. All right, so our key defs are maps that map source keys to the as deliverable URLs, right? So here's my source map. So my map has a key scope at its root, says which publication it is. And I've got a topic ref that's going to get me with a key that gets me to some topic. What that becomes is my deliverable key def map. My map has the same key scope, right? So this is bundle DevOps, same key scope bundle DevOps, but now I have a set of key definitions for the same key that get me to all the different places that topic might be published. And I realize that's way too small for you to see, but that's all right. So what this becomes as the transform that generates this delivery key def map is a single key now becomes a key def per delivery target. So this is saying for this key, go to, if my delivery target is our production server, then this is going to docs.servicenow.com. If my delivery target is our staging service, then this is our staging server. If it's going to somewhere else, we actually generate now 5 or 6 different key definitions for each key for different delivery targets, right? But this is done through a relatively simple XSLT transform, right? So we have deliverable specific key defs for each source key, right? So, and then just normal DITA-OT filtering at processing time just filters down to the delivery target you actually care about, right? So nothing too magical there. The key definitions include the title of the target topic with all of our string keys resolved. So like we heavily use string keys for things like product names and anything that can change. So those need to be resolved in the context of these delivery key def maps because the delivery key def maps may be processed in a context where those string keys are not themselves resolvable, right, for various reasons. So that allows us to have normal cross-reference resolution reflect the title of the topic in a different publication, right? which is important. We also include title-only key defs because we have contexts where we publish our content. We might publish a specific map and not publish any of the other maps, meaning that the cross-references from that map to the other maps don't actually have anywhere to go. Right? One of the things we do is we publish our release notes before the product is officially released. That publication is referencing documents that haven't been published yet. And so for that, we need title-only key defs. So you get the title of the topic that you're pointing to in this publication that hasn't been published yet, but there's no link to it because there's nowhere for it to go. And then the last thing is my delivery key def maps get generated as though they had been produced by the normal pre-processing of OpenToolkit, right? Because OpenToolkit, takes your input map, generates a temporary version of it, and it adds some stuff to it, like some processing instructions that tell it where things are, all the class attributes are instantiated, and so forth. So we just generate that so that OpenToolkit is happy and doesn't know it didn't generate them. All right, so what do? So we're replacing the peer map refs with delivery map refs. So the real hack here, like the real ugly hack, is I hook pre-processing pre to actually take our source map, modify it in the source location to replace the peer map refs with map refs to the copies of my delivery key def maps that I'm going to make. So that when it then goes to normal OT pre-processing, everything is just normal. So this is the big hack here. So I take the input topics and I get a distinct set of referenced keys, right? So I can do that relatively easy with XSLT I have lying around. In particular, I have XSLT library that's in DITA community that will do map resolution, right? So take an input map and resolve all the submap references to create a single XML instance in memory that then I have access to all the topic refs, which mean I have access to all the key definitions, right? Then I read my delivery key def map from my master Git repository where my Jenkins job that generates it put it, and then I just filter out the key references or the key definitions that I don't need, right? And then I write that result to the source location in where the actual documentation source is, at the place where the peer map refs would have, so I've swapped out the peer map refs for local map refs. This is the local map that they're referencing, right? So I've made this filtered copy of the delivery key def map in my source location. I've changed the map refs to point to that, and then I give the rest of it to OpenToolkit processing, and it just does what it does, right? Yeah, so I rewrite these peer map refs with the local scope map refs, right? There you go. All right, so I have demo here, but I'm not really.
1 minute.
I only have a minute. Yeah, so I wasn't going to do a demo, right? So anyway, there's an XSLT that does this. It's not that complicated. There we go. At the beginning of what we call our full family builds, we generate these. We also do it on a timer, right? Because we might publish individual publications on demand. We want to make sure that the cross-deliverable key def maps are as up to date as possible at any moment in time, and then they're in a separate Git repository. There we go. All right. So it was easy to implement. Works well with our CI/CD builds. There's an issue with key refs to elements within topics. That doesn't work yet. And another frustrating thing, especially now with what we heard this morning, I can't use preprocess 2 because there's a chunk bug in 3.x that I believe has been fixed in 4, but we can't move to 4 because we have dependencies on another toolkit plugin that we don't own, blah, 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 right? Reasons. So there you go. All right. So what's the future? So support non-topic key refs. We don't have very many in our content. I think we only had like 14 last time I counted out of 50,000 topics, but we're going to have more. And then move to OT4X and preprocess 2. And if I do that, then I can be more dynamic, and I don't have to do this rewriting of the peer map refs. I can just do that magically in XSLT, but I'm not there yet. And then I'd like to fix the issue with the OT key processing, so that I don't have to do the filtering. And then eventually, we'd also like to enable local builds for authors. They can't do that right now. They can't do a build on their own machine. They have to wait for it to go through our time-consuming build process. So, there we go. All right. And there's 0 time for questions.